Bottoms, please.
Would you like to introduce our first guest for us, please?
Go up in the front.
Take the long way. God, come back.
My grandpa.
Welcome to Scott's Weather Class.
All right, and then fourth graders, this is Rhett. Is that okay to call you? All right, and he's from the National Weather Service. So all right, now we've been studying weather and how weather happens, and they're doing a weather report, actually, a written report that's due next week. So they're going to really listen, and then they might have a couple questions for you as well. So, you guys, do you need anything, water or? All right, gentlemen. I don't know who's.
I'll go first.
All right, perfect.
Hi. I'm going to tell you a little bit how I got into weather way back when. And it was very simple. I ran around, I was raised in Seattle, Washington, where, as you know, they have a lot of rain and clouds and things like that up there. I was always interested in weather. And one of my very good friends that I ran around with, he belonged to the Navy Reserve, and he went away on his 2-week training trip one summer, and he came back with all these wonderful colored weather charts that just bedazzled me. So I said, that's what I want to do. So out of high school, I joined the Navy, and I was lucky enough to go through their weather schools, both one in Oklahoma and one in the East Coast in Lakehurst, New Jersey. And went over to Japan for a while and up to Seattle for a while. And then when I got out of the Navy in 1958, I decided to make it a career. So I joined the National Weather Service. And my first job was at a little place called Tatoosh Island, which is, this is Washington State here. Tatoosh Island is right on the corner of where the Straits of Juan de Fuca go into Puget Sound up in the Pacific Northwest. Little island, 1/8 of a mile offshore. You had to go by boat. And the Coast Guard took you out. As I recall, I went from Seattle to Port Angeles, stayed overnight in Port Angeles. The next morning, you were to meet the mailman, pay him $3, and he'd give you a ride out to Nia Bay, where the Coast Guard station was. Then you transferred over to a Coast Guard boat, and we took a 7-mile trip out to the coast to where the island was, and the island was out there, and he says, there's your new home, and you can see the island looming up just offshore. And you kept looking for a dock, and there was no dock. So I said, how are we going to get up on this island? So pretty soon I see this big puff of smoke go up on top of the island, which is some 80 feet straight up. And out swings this great big boom with a 4x4 basket on it and lowers it down on the end of the boat. And the Coast Guard man says, okay, jump aboard. Jump aboard, and hit the gas, and up we went, and swung us into the island. So that's how we got on and off the island. So I stayed there for several years, enough time that they came and installed weather radar, which was my first experience with weather radar. This was back in 1960, 61-ish. And from that point, I went down to my first tour in Nevada, Winnemucca, Nevada. For a little while, I had a chance to go with the Atomic Energy Commission out to a warmer climate in the South Pacific. I ended up in Eniwetok and Kwajalein Islands down in some 5,000 miles southwest of the United States, and I stayed there for a couple of years. And I came back and ended up back in Fresno where Grandma and I met. And then we came back to Winnemucca, got married, and I think her mother thought that was probably the last time she'd ever seen it because he'd never been out of the state of California. But anyway, she ended up coming up to Winnemucca and seeing us, and as a lot of grandmas do, got hooked on a nickel slot machine for a long time, but they had a lot of fun, and we ended up going back to Hawaii for the National Weather Service, and after Hawaii we ended up in Los Angeles, at which time I, as they like to say, jumped over the bookcase and went over to the Federal Aviation Administration. I kept up my weather duties for quite a while until I went into supervision and management, and I stayed in the FAA until I retired in 1994 here in Reno. So we've traveled a lot. Scott's mom was born in Inglewood, California. The first daughter was born in Hawaii, and the third daughter was born in Tucson. So as you can see, I was born in Michigan, and Judy was born in Fresno. So as you can see, we get around a little bit. Anyway, what I've got here is a few products on the way we used to do weather. It was all done manually. You were trained to be a weather observer. There were several types of observation. Surface obs were the most popular method for gaining a lot of information. And to supplement that, they had upper air, where they sent the big balloons aloft with a transmitter, and it sent back a signal, and then that signal was analyzed into temperature, wind direction, and velocity, which went into a network of information that went to the forecast office, and there they analyzed the data, and the byproduct of that, or the result, was your daily forecast that you hear on the news and radios and all over. And so I'm here to tell you how we used to do it, and Rhett's going to kind of take over and tell you, give you a little touchy-feely on a few of the things that we still use, and the new method they do it, because technology marches on, as we know, and everything is pretty well computerized now. I was fortunate enough to go from the teletypewriter age, which was electronic teletype system of sending data in code, all the weather data in code. So you had to know how to put it into code, take it out of code, and then analyze it. And you had to know how to operate teletype equipment. When I retired in '94, we were just getting into the computerized systems with color weather charts on TV screens, and able to manipulate the data to whatever the pilot needed for his flight. So I was fortunate to go from all those various stages through there to the final stage we are at. And since my retirement in '94, I know they've gone a lot further than that. So, in fact, I was at Winnemucca where they had the upper air station before they even moved it here to Reno. And we were advocating that even when I was back there in the 1960s. But anyway, it's here at Reno now where the forecast office for the whole state of Nevada is located. So with that, I'm going to pass around some charts that you can see how they plotted the charts. And hopefully I'll explain them. These date back to 1957, and they're in the Japan area. And if you look real close, you can probably pick out some of the geographical features, and I'll help you with the one up here.
Okay, please be really careful with those.
You can see up in this area, there's a light line coming around, which part of Alaska coming down into the Aleutians, and then the Japanese island chain is here, and then this is all of Russia and China, and you go down into here, you get down into Philippine Islands and marijuana and stuff like that. And these were all hand plotted by Japanese technicians that we had in our office in Atsugi, Japan, which is roughly 40 miles south of Tokyo. They'd plot the maps for us. We get the information in by teletype. They plot the map. And then a lot of times when officers were busy with other duties, we would get to analyze the charts, and then they would check our work behind us before they put out the forecast for the airplanes. And most of my weather experience has been in the aviation part of weather. And some of these, let's see, I got it. All these little stations, they call them station models. You see them all, a lot of these are ships out in the ocean here, but there's a lot of weather stations all over. I couldn't even hazard to know how many weather stations, even back in my day, they had a lot of them. But anyway, I can pass this around too, but it shows the station circle, and around that station circle, the circle in the middle will, by coding, you can tell whether it's partly cloudy, overcast, whatever, by coloring in the circle to a certain amount. And the bar you see extending out is from which direction the wind is coming, and the pennants that stick out on that represent the speed of the wind. As you go around the circle, it puts temperature and dew point, the pressure, visibility, restrictions of visibility such as rain showers, fog, and all these were symbolized way back when. And I put the symbols down at the bottom, but back in weather school, you can just go ahead and pass that around. back in weather school, that was one of our duties. We had to memorize some 99 symbols, from rain showers to, I guess I could put a couple of these in. They go from a dot meaning rain, to a comma meaning drizzle, to a dot over a triangle meaning a rain shower, to an asterisk over a triangle meaning a snow shower, and they can go from intensity. If it's 2 dots, it means that's the type of precipitation it is. If it's 3 dots, it's a little heavier. And visibility, they put just by miles. So when it gets less than 7 miles visibility, we used to have to put a reason why we couldn't see any further. So you'd always have like 5 miles visibility and something after it. If it was fog, might be 3 bars like that for a very thick fog. So, but we had to memorize all these because when we were plotting these in weather school, all of these little symbols had to fit under a dime, and you were checked for that. And I forget how many we had to plot. I think we had to go 1 to 2 a minute to be graded on. They had all to be, you had to be able to read them and all that. And you just couldn't dilly-dally because we plotted a chart once every 6 hours and sometimes every 2 hours. If you have any questions as we go, it's okay to ask them.
Did you ever get put on TV to do like some days or weather?
A TV weathercaster? No, I never did that. I thought about it when I retired, but I was too lazy.
Do you know a bird swallow?
I do.
That's my grandpa.
Oh, well, yes. He was in the Weather Bureau here, and I was on the other side. Yeah, I have no idea. They were for me. No, I never have. The closest I came to a tornado, I was traveling from Los Angeles back to Oklahoma to go to an FAA school, and I got out of, I just came up from Texas into Oklahoma, and I stopped to get a Coke, and I heard the sirens go off, and I immediately saw everybody going into the shelters, and I took off out of town, and I had the radio on. They gave me the alert, so I turned right around and went back in, and it went away from the town, but that's the closest I've ever been.
How far do you have to wait for a tornado to
As far as you can get. You don't want to play around with tornadoes. They do have certain paths of movements, but they're very, very erratic. I always was explaining the path of a tornado like, remember these tops that they had a ratchet in it and they'd spin? Well, as it's spinning, it also wobbles, and that's what tornadoes do. And they bounce around, they hit the ground, they stay on the ground for a long time. Some of them stay longer, but that's how erratic they are. They're getting very, very good on when they're coming down and what the intensity of them can be and things like that. But exactly where they're going to hit, you almost have to be right there when it touches to see it.
Wait, so did you ever go like on land to do this? Like you had a base like on land, like in the United States, not like on an island, like over like on land.
For observing? Yeah, I was up at Winnemucca, and then I was at Winnemucca a couple of times, and we did radio broadcast. That's the closest I got to TV was radio broadcast there. But yeah, I observed at LA International for a number of years, and Winnemucca, Fresno, and up in the Washington State area.
Like, I know the barometer, I know it helps you like check air pressure, but what do you need to check? What air pressure do you need to check for?
That's a good question. Well, air, as you know, air kind of presses down, and the resulting factor the result at sea level, which all these charts are based on sea level, is what that pressure is. And there's certain, as highs and lows, high pressure is just what it stands for. High pressure, low pressure is as they move and migrate around the globe. it changes the pressure as it goes. And so they can tell by when these pressures are falling, if the storm's going or if it's going away, and things of that nature, and that's how we use that barometric pressure.
Thank you. How many days does it take for a hurricane to form?
Hurricanes, they can, I would say, what, 3 to 5 days maybe? It depends on the energy involved. And as you know, they're a tropical disturbance, and as long as they have the energy and some movement, and they start off as an they call it an easterly wave. Then the wave forms a circulation, and the circulation, if it's fed enough fuel, like heat and water, it'll just keep building in itself until it just runs out of fuel. Let's just go.
How do the hurricanes stop?
I didn't hear it.
How do the hurricanes stop?
Most of the time, when they're traveling, they'll curve up to the north and they'll get over land and break up, or they'll get over a colder air mass or land that breaks them up, and then they'll start breaking up, and then they just become a regular storm and get into the rest of the weather system and move off.
How many hours or minutes does it tornado, like, how many hours does it take for a tornado?
Well, tornadoes, as you know, they come down from the clouds, and there's a lot of theories on how they form. I've got a couple of them myself, and I don't know how good they are, but anyway, they'll come down from the clouds. They can stay on the ground quite a while. I think they can stay on the ground sometimes 15, 20 minutes, maybe even longer. Sometimes only a couple seconds. Sometimes they don't reach the ground. And does anybody know what it's called if they don't reach the ground? Anyway.
I know, just that.
You know?
Funnel cloud.
Funnel cloud. That's when they don't reach the ground. And you know, the only reason you can see tornadoes is because they got dirt and water and stuff like that that they suck up from the ground. That's a lot of times the only reason you can see them. Let's go over on this side.
How many miles per hour does, like, how fast does the wind have to be?
The tornado. Well, they've been reported, what, up to 300 miles an hour in its own circulation?
Yeah,
They move, they'll move with the weather system, and sometimes they can move up to 60 miles an hour across land, but the actual, they call it the vortex, the actual spinning can get up to 200 to 300 miles per hour. All the same question? Where do I go? How about you?
With hurricanes, how fast can, like, the winds be blowing?
Hurricanes, they'll go up, hurricanes will go up as high, they've gotten over 100 miles an hour right outside in the eye where the eye is, where it's the calm. But they can go up to over 100 miles an hour. And they're classified by the prevailing winds that they measure as they go. I think it's 64 knots and above is a hurricane. 64? Yeah. And then they get higher from that. Below that, it would be a tropical disturbance. Let's go to the teacher.
I want to go back to these symbols because that's amazing. So on a day like today, what would it look like?
Well, if we just go walk outside, I'll just guess. Here's your station model. It's got some real high clouds. So this might be all colored in because we've got a layer of real high clouds. But if it's a cirrus, it would be a symbol like this, maybe, or one like that. And maybe the wind's out of the east at 5 knots. And we probably have more than 15 miles visibility. There's no restriction. And I'll guess on the temperature 72. Maybe the dew point down here. Dew point's like a measure of relative humidity in a sense, and it's probably very low, maybe 45. And then the pressure, whatever the pressure is at sea level, in millibars would be 10, 14. And then here would be a pressure tendency, which it just gives an idea of what the pressure's been doing in the past 3 hours.
All right, so tomorrow, if I ask you what the weather's like, that's how I want you to write.
What? No way.
Better take a picture of this little guy here. And by the way, before I forget, don't let me forget, I'll give it to you right now.
Okay.
You can borrow this, and Brett says it is available. That's a 92 model, but you can get them out of Random House, I guess. Okay, Now this one, this is called a Nimbus satellite picture. When I was working in the National Weather Service in Los Angeles, down in this area, we had a telephone line up to Vandenberg Air Force Base, and they would track this Nimbus 2 weather satellite, which was one or second or third satellite up for the West Coast anyway. And it passed, I can't remember the exact parameters, I think it was once every 96 minutes it passed over Los Angeles. But anyway, they would send this down by telephone line, and then we had a receiver that would print out the picture, and all you got was just the picture of the clouds. Like these, here's a little tropical disturbance here. But all these little whiter ones are clouds, and then you had to figure out where you can see the Baja Peninsula, and you had to figure out the middle of the pictures and kind of make them, came in as a puzzle, you kind of had to put the puzzle together in the olden days. But that's how we used to do it back in there, and it was relatively new. This was in 1967, so you can see from 67 on, we've come a long way on satellite.
What time of year do tornadoes like mostly form?
Tornadoes, right now is tornado season back in the midsection of the United States, as you probably see by the news. They can technically form any month, but right now is a good time of the year when the cold air out of the north meets the warm, moist air out of the Gulf of Mexico, and when they collide together, that's when you get the actions happening back in the Midwest. And it'll go anywhere from Texas clear up into Minnesota and clear over to Kentucky.
Is it possible for hurricanes to like cross midway in the United States, like get to midway?
Hurricanes are pretty much tropical. And if you remember Katrina several years ago that went across New Orleans in the southern part, that's when they start curving and coming back up to the north. And they dissipate pretty rapidly once they go over land, but they can be very, very powerful as they come on shore. And of course, you know, it makes the oceans surge up and all those kind of things. And the wind, very heavy rain and wind factor, and they have thunderstorms in them. Oh, that's the other one I've got, sure. That's probably the most interesting one, the thunderstorms symbol.
Oh, maybe doing.
Whoa, looks like
And
an
then
R with
if you
like
leave
a
off, if you just do this, it's like,
right angle. It looks like an R with the right angle. I know,
Huh?
yeah.
looks like I got the anchor on it. How about back in the back there?
Looks like it.
Tsunamis, one of my favorite subjects. Tsunamis, now that's a little different. I guess you can have it, sometimes they try to relate it to weather, but that's really I think a geographical type thing. When you displace a certain amount of water, it's got to go somewhere. And that's what happens in a tsunami. Usually an earthquake or a landslide can cause it, but something causes the water to be displaced. And as that water moves, it can create the tsunami, and it can travel very, very rapidly. We happen to be in Hilo, living in Hilo, Hawaii on the Big Island, when they had the Valdez earthquake, and the tsunami came through there at 17 inches high, if I remember. So we had a tidal gauge there that measured that, and as I remember, it came through at 17 inches high. But the warning system, of course, immediately goes into effect when anything like that happens, like the one in Sumatra and the one in northern Japan more recently, that created those huge waves that go, and they'll travel up to 300-400 miles an hour, believe it or not. Out in the ocean, you won't notice too much other than a big rolling wave, but as they get closer to the continental shelves, which point down, some of them can be like this or like this, then they'll roll up, and then the wave really gets big, and then of course crashes over on itself. How about in the green?
Why do tornadoes usually happen in flat grounds and not in the mountains?
They can happen in the mountains, but they're more rare. In fact, I think just a couple of days ago, Denver had a tornado. But it's not that they don't happen, but in the Midwest where it is flat, and the thunderstorms back there are really granddaddies. They're big, big clouds. They call them supercells. And they go up very high. They go up to 50, 60, 65,000 feet. And they move rapidly, and And the base of some of those clouds could be miles and miles across the part, but out in the west coast, we do get them once in a while. Down in Los Angeles area, you get a funnel cloud once in a while. And in fact, there was even a very small one reported here when I used to work there years ago, but it just touched down once and disappeared. So they can happen anywhere, but they're not as prevalent on the west coast as back in the Midwest.
How wide can I turn it? 2 miles.
Couple of miles?
Yeah, they should be-
I've
yeah,
heard them
2
reported
miles.
up to at least a mile, a half mile to a mile wide.
Let's take 2 more questions.
Okay, then we switch over.
Yeah, so-
Let's see. Who hasn't had a chance to do a question? How about you?
Well, I know how like the Earth rotates and like that's how like weather like changes, but like how like sometimes around here like we'll have raining for 15 minutes and then it will be sunny. And then how does it change?
Well, that's normally, my guess would be that's probably a showery condition. You got those big white fluffy clouds and the wind's pushing them along and they get enough moisture to drop some rain and then they move on and then in between is sunny. And that brings me up to the good old adage of Reno, if you don't like the weather, just stick around 15 minutes, right? Who else hasn't had a chance to have a question? How about in the black?
Have you ever been in a blizzard or seen a blizzard before?
Yeah, coming down from Pendleton, Oregon, eastern Oregon, across the Blue Mountains into Burns, Oregon, and just north of Winnemucca. I hit a blizzard there back in, I can't remember, 1961 I think it was. I just had to turn back and stop. I couldn't see anything, so I think that was our last question. Let me turn it over to Rhett, and if I've made any mistakes, I know he's going to correct me. But anyway, Rhett's a meteorologist from the National Weather Service, and he's going to show you a whole bunch of stuff by PowerPoint and some anemometer and rain gauge and stuff like that. Thank you very much.
All right, thank you.